welcome to the Explainer. So if you've ever found yourself pulling your hair out working with Cisco ACI, just trying to answer a simple question like, where in the world is this device connected? Trust me, you're not alone. Today, we're going to demystify endpoint connectivity and show you exactly how ACI keeps tabs on every single device in your network.
All right, here's what we're going to cover. First, we'll talk about the kinds of mysteries we're always trying to solve as network admins. Then we'll get into ACI's totally new rulebook for learning about devices. After that, we'll dig into the tools, both in the GUI and the command line, before we finally pull back the curtain on the secret sauce, this really cool protocol called COOP that makes the whole thing tick. You know, as a network admin, your job is basically part detective, right? You're constantly getting hit with questions about what's happening on your network, and you need answers fast.
And these are the kinds of questions Cisco ACI was built to answer. It's about more than just, is it up or down? It's about providing some really deep visibility. But, and this is a big but, to really use that power, you gotta kind of rewire your brain a little bit and grasp ACI's unique way of thinking about the network.
So, what's ACI's big idea here? Well, it pretty much takes the old networking rulebook and tosses it right out the window. It completely changes how network information is gathered and stored, leaving behind all those separate tables we're so used to. And this right here, this is the absolute core of that shift. In the old world, you had your MAC address table over here, your ARP table over there, your routing table somewhere else. ACI says, nope, let's get rid of all that. Instead, you get one big, beautiful, unified endpoint table. The cool part is how it learns. It's not sending out RPs asking, who has this IP? It just watches the traffic and learns both the MAC and IP directly. It's just a much, much smarter way to build a map of your network. And that's the key takeaway here, this endpoint thing. It's the fundamental building block of identity in ACI. It's not just a MAC address or just an IP address. It's the whole shebang rolled into one. It's a complete identity for a device, which gives the fabric a way richer picture of who's talking to who. Okay, so if we want to go find these endpoints and figure out what's going on, we first have to understand that they come in two main flavors, local and remote. Think about a local endpoint like this. A server gets plugged into a leaf switch. The second it sends out its very first packet, that leaf switch goes, hey, I know you. You're connected right here on this port. That's a local endpoint. It's the ground truth, the primary source of information. And once the leaf learns that, it shouts it out to the rest of the fabric so everyone else knows. Now, remote endpoints, that's a whole different story. Think of these as things you learn through the grapevine. Let's say leaf A needs to talk to a server over on leaf B. When that traffic comes across, leaf A learns about that server as remote. It's like, oh, I don't know this guy personally, but I know he hangs out over there. And that's why the entry is temporary, right? It's just a little cache entry that sticks around only as long as those two endpoints are chatting. All right, enough theory. Let's get our hands dirty and start investigating. First up, we'll use the graphical tool, the APCO ACI. This is going to be your go-to for getting that big picture view and digging into the history of what's been happening. So a really handy place to look is inside an EPG, an endpoint group. Just navigate to your EPG, pop open the operational tab, and boom, there it is. You get this super clean list of all the endpoints currently living in that group. It tells you their addresses, the exact port they're on, and even how the fabric found out about them in the first place. But remember that question from the beginning? Hey, what was plugged in last Thursday afternoon? Yeah, for that, you're gonna need the EP tracker. This thing is an absolute lifesaver. It's like a time machine for your network. You can punch in a MAC, an IP, whatever, and it will show you the entire life story of that endpoint. When it connected, when it left, and everywhere it's been. It's just awesome for troubleshooting. Okay, the GUI is great for history and overviews, but when you need to know what a switch is thinking right now, for the nitty-gritty, real-time forwarding decisions, we've got to jump into the command line. And the command you're going to live by is show endpoint. Just burn that one into your brain. It's basically show MAC address table on steroids. It gives you all the MAC info you're used to, but it also ties in that all-important IP address. And listen up, because this is a super important detail you have to get right. Where you run this command completely changes what you see. If you run show endpoint on the APIC, you're getting the master list, right? The whole fabric-wide view of every local endpoint. But if you run that same command on an individual leaf switch, now you're looking at its personal little cheat sheet, the specific local and remote entries it's using to make decisions this very second.
So you're probably thinking, how does that even work? How does one little leaf switch know about all these other endpoints across this massive fabric?
Well, that's where the real magic, the secret sauce, comes in. And it's a protocol called COOP. COOP, the Council of Oracle Protocol. Yeah, it sounds pretty epic, and honestly, it is. This is the single source of truth for the entire fabric. It's the communication backbone that makes sure every spine has a perfect, up-to-the-minute map of where every single endpoint is. Here's a great way to picture it. Your leaf switches are like little reporters out on the street. They see an endpoint connect, and they report that fact up to the spine switches. And the spines? They're the oracles. They sit in the middle, collecting all these reports and maintaining this massive, shared database of truth about where everybody is.
And because of this co-op system, you get a couple of seriously cool features. First, you get spine proxy. So if a leaf sees traffic for a destination it doesn't know, it doesn't have to freak out and flood it everywhere. Nope, it just punts the packet up to a spine, and the spine, the oracle, knows exactly where it goes. Then there's endpoint dampening, which is basically a built-in defense system that stops a flapping or buggy endpoint from driving the whole fabric crazy.
So here's the bottom line. Once you really get your head around ACI's endpoint table, once you understand local versus remote, and you know which tools to use, you can pretty much solve any connectivity puzzle you'll ever face. And that leaves us with a bigger question to chew on, right? As our networks get smarter and more policy-driven, are we heading towards a future where the only thing that really matters isn't the path, but just the endpoint's identity?